Hello friends, today we are going to discuss the topic transformer related to subject energy conversion for electrical branch. Before going to start transformer, we should know why transformer is needed in our day-to-day life. So for that, I just say about some electrical network where transformer is needed. First, in your electrical network, we have four stages. First one is generating station or power plant. Second is transmission. Third one is distribution. Last one, fourth is utilization. As you know, electrical power generated from power plant that is called generating station. Here the generating power having 11 kV to 33 kV voltage rating. Generally in our India, it is set up 11 kV to 33 kV. Come to utilization, where we utilize the electrical energy. Here, the voltage rating of utilization is 230 volt to 440 volt. For domestic purpose, it is 230 volt, and for commercial purpose, it is 440 volt. So you can see that the voltage rating is lower down from generating station to utilization sector. Generating stations are situated where the facility available of raw material means hydropower plant related to waterhead, thermal power plant related to coal, fuel available area that is far away from load center. Load center means where we are staying or electrical power is utilized. So for receiving the electrical power, we need some two steps, that is transmission and distribution. For economical aspect of electrical energy, in your transmission line, the voltage rating, whatever the power plant having, it is raised up to 10 times of power plant voltage rating. That means at power plant we have 11 kV. For transmission line, it is raised up, means it is 132 kV or 734 kV. So you can see that the voltage is raised up. Again, for distribution purpose in your grid substation, it brings down. Again, it is stepped down. For utilization purpose, again it brings down. So you can see in four steps, the voltage is step up and somewhere it is step down. This variation of voltage is done by a system or a device that is called transformer. So transformer needed for electrical energy based upon the required voltage. So this is the need of transformer, why transformer needed in your electrical energy or electrical system. Now come to the definition of transformer. For definition of transformer, everyone see the transformer at substation, at power plant. Here you can see there is no rotating part in your transformer. So it is called a static device. Static means there is no rotating part involved in your transformer machine. And electrical energy transfer. That's why it is called transformer. Electrical energy transfer from one AC circuit to another AC. And the energy transfer from one circuit to another circuit is not minimized or maximized. The value which are varying, that is voltage and current of the electrical system. So in general method, the definition can be written as transformer is an static is an electrical static device by means of which electrical energy is transferred from one AC circuit to the another by desired change in voltage and current without changing its frequency. Why it is called static device? Already I mentioned there is no rotating part and it transfers electrical energy from one AC circuit to another. There is no DC source provided to transformer, and here voltage and current value is varying. No power limitation is available. And one more thing is frequency remains constant. Whatever the supply frequency available, same frequency will transfer at the output of. So this is the proper definition of transformer. Then we go to the working principle of transformer. So before going to working principle of transformer, we just need a basic or simple transformer structure that I will go. In your transformer, we have a magnetic core. I just draw a rectangular core. One side of core is wound by the help of wire. Same opposite of that, another winding is available. One side of winding, I provide supply, that is AC supply. The supply provided to the winding is called primary winding. Just opposite to primary winding, the load is connected. Same at side of load, the winding is called secondary winding of transformer. So this is your AC supply. This is your primary winding, your secondary winding, that is your load. Then this one is your core, rectangular shape core, I just draw. This is the basic structure. In your core, then we supply AC current or AC voltage. Current I1 is flow to the primary winding. We know that when one coil is carrying a current. The coil gets magnetized and magnetic field is created. So the field which is created will link to the core, and that is through the electromagnetic core. I just draw the dotted line. The path of magnetic flux. I. The flux is linked to the core. Here, two winding is available, and they are called inductively coupled. That means there is no electrical connection between two windings. Only magnetically they are coupled. That's why it is called inductively coupled. Inductively coupled means no electric connection between two coils. So this is the basic structure of a transformer: magnetic core, primary winding, secondary winding. This is the path of magnetic flux which is linked to the core. Now, for working principle, every machine must obey some rules or law. In your transformer, it obeys or follows electromagnetic induction. First is Faraday's law of electromagnetic induction. Second law it follows, that is called mutual induction. So transformer working on the principle of Faraday's law of electromagnetic induction and mutual induction. Here in your primary winding, then I1 current is flowing. Ultimately, magnetic flux is set up. But Faraday's law of electromagnetic induction says when the flux linking to a circuit is changed with respect to time, there is an EMF set up inside the circuit. So we found some flux in your primary winding which is linked to the core. Definitely it is an electrical circuit. So definitely some EMF is induced. Let it be E1 in your primary winding. So based upon Faraday's law of electromagnetic induction, E1 is set up in your primary winding. So same flux linking to the secondary winding, but mutual induction state if two coils are inductively coupled, we provide one coil to the AC supply, then current is flowing in one coil, and EMF is set up or raised in secondary coil by mutual. That is why it is called mutual induction. Means in one coil current is some EMF is set up in other side of coil. So then linking to the secondary side, again the linking of the flux to the secondary side is changes with respect to time. Hence, same some amount of voltage is set up in secondary winding, let it be E2. So this E1 is set up by Faraday's law of electromagnetic induction, and this E2 or EMF set up by mutual induction. We provide DC supply, value of flux setup is remain constant. But the flux linking to the circuit changes, then AC supply is available. As you know, AC means alternating in nature. With respect to time, the value or magnitude of quantity is changed. So flux is set up, linking is changes, hence EMF is induced. Same case, alternating flux is linking to the secondary winding. Flux is create an EMF peak. That is by mutual induction. So this is the basic structure of transformer, and it follows the Faraday's law of electromagnetic induction and mutual induction. As here E2 is set up, then a load is connected, this circuit is being closed, some amount of current is flow, let it be I2. So here some energy set up transfer to the secondary side. So electrical energy is transferred from one circuit to another by magnetic coupling action. So this is a basic working principle of single phase transformer. So here we can see the value of E2, EMF of secondary side is given by M di by dt, where the current is linking to the primary side, but voltage is set up from secondary side. So this value is coming from mutual induction. The magnitude is M di by dt. M means mutual coupling effect. So this is the basic working principle of single phase transformer. Now everyone should know what is core. Core means it is a magnetic material where it provides path for magnetic flux. This flux, the nature of this flux always alternating. If it remain constant, there is no chance to set off EMF. This is a major factor. Hence, one concept is clear. AC means alternating, flux is set up is alternating. If we provide DC, the flux remains constant, so no EMF is set up, or this EMF is also called back EMF of the transformer. When flux is constant, this EMF is not set up, and no electrical energy is transferred from one circuit to another. When we provide DC supply, this primary winding having small amount of resistance, it draws heavy amount of current. This may burn out the winding. So to prevent the winding burn, we must keep in mind the supply must be it. Thank you. So in this class,